In the world of AI, starting every single project from scratch it's just not the smart way to go anymore. Today, we're talking about the clever shortcuts that give AI a massive head start: transfer learning and domain adaptation. These two ideas are absolutely changing the game for how we build and use artificial intelligence. So let's dive right in.
So, to really get why these shortcuts are such a big deal, we first have to ask, what's the single biggest roadblock for AI development? What's the one thing that every powerful model is absolutely desperate for?
And the answer, almost always, is data. But here's the catch. It's not just any data. It's labeled data. Training a model from the ground up needs a literal mountain of it. And building that mountain, it's incredibly slow and unbelievably expensive. And that right there is the exact problem that these techniques are built to solve. Okay, so our first solution is something called transfer learning. And honestly, the name kind of says it all. Instead of forcing an AI to learn everything from square one, we give it a huge advantage by letting it reuse skills it's already mastered. The whole idea is actually pretty simple, but it's incredibly powerful. Think about an expert artist who has spent years mastering landscape painting. Now, if they decide to start painting portraits, are they starting over? Of course not. They already understand color theory, how to use a brush, perspective, all the fundamentals. They just transfer that knowledge to a new but related task. And that, in a nutshell, is exactly what transfer learning does for an AI. So how does this actually work? Well, it's basically a three-step dance. First up is pre-training. You take a huge model and train it on a massive general data set. We're talking like all the images on the internet. From that, it learns to extract general features, figuring out the basics of our world like edges, colors, and textures. Then, once it has that solid foundation, you move to the final step, fine-tuning. You take that pre-trained model and just tweak it for your very specific new job using a much, much smaller set of data. Let's make this real with a quick example. Imagine you want to build an AI that can analyze medical images. Instead of starting from absolute zero, you could grab a model that's already been pre-trained on a giant database like ImageNet to identify thousands of everyday things. That model already has this deep, intuitive understanding of shapes and patterns, so it can then apply that foundational knowledge to the totally new task of spotting diseases in medical scans, and it'll get up to speed way, way faster. And the payoff here is just massive. You need way less data for your new project, the training time gets slashed, and since the model had such a great head start, the final performance is often way better. It's a huge win all around. All right, now for the second piece of our puzzle, domain adaptation. This builds on that same core idea of reusing knowledge, but there's a really important twist. If transfer learning is all about applying old skills to a new task, domain adaptation is about using the very same skill, but in a completely new environment. So let's get a tiny bit technical for a second. In AI, a domain is really just the context or the style of your data. The problem that domain adaptation is designed to solve is something called domain shift. This is what happens when you have a model that was trained on one type of data, and suddenly it has to work with data that looks totally different, even though the job it needs to do is exactly the same. Here's the perfect example. Let's say you train a model on the famous MNSTS dataset. It's full of these super clean, perfectly centered, handwritten numbers. Your model becomes an absolute expert at reading them. But then, you take that expert model and show it blurry, real-world photos of house numbers. The task hasn't changed at all, it's still just identify the number, but the domain, the context, is completely different. And without some help, that expert model is probably going to fail badly. So the process here is a little different. You still start by training a model on your original, clean, source data. But then comes the magic step, domain alignment. This is where you use clever algorithms to find the common ground between the two domains, essentially teaching the model to see the underlying similarities between the old data and the new, messy data. Once you build that bridge, then you can fine-tune the model on the new, target data. And the benefits here are all about making AI more flexible and more useful in the real world. It directly tackles that problem of domain shift. It means you don't need tons of labeled data for every single new environment. And ultimately, you end up with models that are just far more robust and reliable when they're out in the wild. Okay, so we've met our two contenders. We've seen them both in action. Now, let's put them head to head to really nail down what makes them different. If you only remember one thing from this whole explainer, please let it be this. Transfer learning is all about changing the task you're trying to do. Domain adaptation is about changing the domain, the context of the data, while the task itself stays exactly the same.
Let's just break this down a little more. For transfer learning, the goal is a new task. And the basic assumption is that even though the jobs are different, the underlying data is similar enough to share knowledge. For domain adaptation, the goal is a new domain. And the assumption is the complete opposite. The task is identical, but the data itself just looks different. Our examples make it super clear, right? A general image model learning a new job, like medical diagnosis, versus a digit reader doing the same job, but in a new place, like on blurry photos. It all comes down to whether you're changing the what or the where.
Okay, so understanding the difference is great. But the real million-dollar question is, how do you actually put this knowledge into action? Let's build a little playbook for when to use each of these powerful techniques.
When you're sitting there with the data challenge, which tool should you reach for in your toolbox? Well, the answer depends entirely on the problem you're trying to solve. So you're going to want to choose transfer learning when your main problem is a brand new task and you don't have a lot of labeled data for it. The trick here is finding a really good pre-trained model that's already learned features relevant to your problem. A perfect example is taking a giant language model trained on the entire web and fine-tuning it to understand the very specific language found in medical notes. On the flip side, you're going to reach for domain adaptation when your task is staying the same, but the environment the data is coming from has changed. This is your go-to when getting labeled data in that new context is either really hard or just plain impossible. Think about adapting a speech recognition model that was trained on adult voices so it can accurately understand the totally different pitch and rhythm of children's voices. Now, as powerful and as cool as these techniques are, it's important to realize they're not the end of the story. They are really just crucial steps on a much longer journey for AI. And it's important to remember these aren't some kind of magic bullet. There are still big challenges, like a weird phenomenon called negative transfer. This is where knowledge from the original domain actually hurts the model's performance on the new one. It's kind of like trying to apply your car repair skills to fix a bicycle. Some of it might help, but a lot of it will just make things worse. It really proves that choosing the right starting point is absolutely critical. This timeline here really puts it all into perspective. Transfer learning and domain adaptation are what's happening right now. They are the state of the art. But they're paving the way for what's coming next. Incredible techniques like few-shot and zero-shot learning, where an AI can learn from just a few examples or maybe even none at all. And the ultimate goal, way out on the horizon, is meta-learning, building models that don't just learn a task but actually learn how to learn. So what's the big takeaway from all this? These techniques aren't just about saving time and money. They're about making AI more flexible, more adaptable, maybe even a little more like us. And as we get better and better at teaching machines how to transfer knowledge, it leaves us with a pretty powerful question to think about. What problems that seem completely impossible today will we be able to solve tomorrow? Thanks for tuning in.